dear students, my name is PankajSinsinwar. Welcome to my channel Maths with Pankaj sir. Today in this lecture we are going to solve past year questions from circular measure. So let us start with question number 1. We will try to solve as much questions possible in 1 hour. So this is question number 1. The diagram shows the equation of a circle x minus 2 whole square plus y square equals to 8, and the chord AB of the circle intersects the positive y axis at A and is parallel to the x axis. So find by calculation the coordinates of A and B. You have to find coordinates of A and B. We know that the point A lies on y-axis, therefore x coordinate is 0. So directly substituting x equals to 0 in equation of the circle. So for coordinates of A, directly substituting x equals to 0 in equation of the circle equals to 8. So y square is 8 minus 4, which is 4. Y equals to plus minus 2. So A is x is 0 and y coordinate is obviously y, obviously 2. It is not minus 2. It is clear from the diagram itself. So now for coordinates of B, we know that y coordinate of A and y coordinate of B are same because the chord is parallel to x axis. So y coordinates will be same for A and B. So therefore I can write y coordinate of B is 2. Substituting y equals to 2 in equation of the circle, I have x minus 2 whole square plus, as y is 2, so 2 square equals to 8. So x minus 2 square equals to 8 minus 4, which is 4. X minus 2 equals to plus minus 2. So therefore x equals to 0 or x equals to 2 plus 2, 4. So clearly it can be seen from the diagram itself that x coordinate of B can never be 0. So I will cancel this out. X coordinate of B is not 0. So definitely x coordinate of B is 4. Therefore B is 4 and y coordinate is B. Y coordinate of B is 2. So 4 comma 2 is coordinates of B. And coordinates of A are 0 comma 2. So these are our final answer. Let's move to next question. Read question number 2. The diagram shows a circle with center A of radius 5 cm and circle with center B of radius 8 cm. The circle touch each other at point C so that ACB is a straight line. The tangent at point D on the smaller circle intersects the larger circle at E and passes through B. Wow. So find the perimeter of shaded region. Perimeter of the shaded region. From the diagram it can be seen that perimeter of the shaded region is sum of arc length of CD plus CE plus length of DE. So I can write perimeter of shaded region is equals to arc length CD plus arc length CE plus DE. So let us make some calculations for all these lengths. I'll make a horizontal line and here I will make all the calculations. So I'll write calculation. Calculating length of DE is very easy. In triangle ABC, we know BD square using Pythagoras theorem is AB square minus AD square, which is AB square is 13 square minus AD is 5 square. So I can find the length of BD as 12 centimeter. I know since BD is equal to DE plus BE. Therefore, DE equals to BD minus BE equals to 12 minus BE. Length of BE is 8 centimeter. So 12 minus 8 equals to 4 centimeter. Okay, now we have to find arc length. For arc length, we need to have angle value of A and value of B. So again in triangle A, B and C, ABD, again in triangle A, D, B. So triangle ADB is right angle triangle at D. So I can write cos of A is AD upon AB, which is 5 upon 13. Therefore, A equals to cos inverse 5 by 13, and put your calci in radians. So you will get this value as 1.176. As it is a right angle triangle, therefore value of B will be 90 minus A. So 90 minus 1, sorry, 90 is pi by 2. As we are taking values in radians, so I will write 90 degree as pi by 2 radians minus 1.176, which will give us 0.3948. So now directly using values of A and B in the question, now I have total perimeter arc length CD. So arc length CD is r theta. R is 5 and theta is angle A, which is 1.176 centimeter, plus arc length CE. CE is clearly r theta, where r is 8 centimeters, and theta in radians is angle B, which is 0.3948, plus length of TE, which is 4 centimeters, which will give us total value as 13 centimeters, and that is our final answer. Find the area of the shaded region. So to find the area of shaded region, I can directly subtract area of sector ACD and BCE from the area of triangle ABD. So area of shaded region will be area of triangle ABD minus area of sector ACE, sorry, ACD minus area of sector B, C and E. Area of sector BCE. So it requires basic knowledge of area of sector formula, which is half r square theta, and area of triangle is half into xy into sine of angle between sides with length x and y. So half xy sine theta. So we have to remember these two formulas. Okay, wait. So now substituting the value of these. So now area of the shaded region will be area of triangle ABD, which is half into 5 5 into, okay, I can also find the value of this triangle without using sine theta, because this is right angle triangle, and I can use half into base into height. So in this triangle, base, I can take base as AD and height as BD. So base is 5 and height is 12. This is 12 and this is 13. So half into base into height, half into 5 into 13 and centimeter square, minus area of sector ACD, which is half r square theta, and r is again 5 square and value of angle A was 1.176 centimeter square minus again half r square theta. For BCE, radius is 8 square and angle contained is 0.3948. So this gives us the value of area of the shaded region, which is 2.67 centimeter square. So let's move to the next question. Now read question number 3. The diagram shows a sector ABC which is part of a circle of radius A. The point D and E lie on AB and AC respectively and are such that AD equals to AE equals to KA. AD and AE equals to KA. If K is less than 1. The line DE divides the sector into two regions which are equal in area. So the area of this triangle and area of this region is same. Okay. So for the case where angle BAC is pi by 6 radians, find the value of K correct to 4 significant figures. Fine. For area of triangle ADE shaded by the red lines. So area of triangle ADE using formula half xy sine theta will be half and xy sine theta AD into AE both are KA. So half KA square half xy sine theta. Sine theta. Theta is angle between the two sides which is given to be pi by 6. Pi by 6 is 30 degree. So we know sine 30 is 1 by 2. This becomes the value of the area of triangle ADE is now K square A square divided by 4. As sine pi by 6 is 1 by 2. Okay. And area of sector ABC. One more thing you have to notice that area of sector ABC will be twice of area of the triangle ADE. Is this clear to you? See, area of triangle ADE and area of this DECB. These two regions, the area of these two regions are equal. And area of sector ABC is sum of these two regions. And both the regions are equal. Therefore, area of the sector ABC will be twice of area of ADE, which is, I think, clear from the diagram itself. Now, area of sector ABC is half r square theta. So radius is a only, half r square theta. Theta is pi by 6 and which is equal to 2 into area of triangle, which is k square a square upon 4. So a square cancels out. I will cancel out a square and a square. Also 2 ones are 2 twos are and this 2 cancel out with this 2, and now I have k equals to, this gives me k square is equal to pi by 6. This means k is nothing but square root of pi by 6, which is my final answer. So I will box it. Okay, let's move to the next part. I think finding k was our objective. Okay, find k. Now let's move to the next part. Now read part B. For the general case in which angle BAC is theta. Okay, so now angle BAC is not pi by 6. This is theta, not pi by 6. It is theta, and theta is acute, which is from 0 to pi by 2. It is given that theta upon sine theta is greater than, always greater than 1. Find a set of possible values of k. Fine. This means area of triangle will be area of triangle ADE. ADE will be half KA square into sine theta, and area of sector will be half a square theta, but it is also given that both the regions are equal. DE divides both the regions in equal areas. So area of triangle, area of sector will be twice of area of triangle. So area of sector will be twice of area of 2 into half k square a square sine theta. This half cancels out with this half. A square cancels out with a square. Now I can write theta upon sine theta will be equal to 2 into k square. So as it is given in the question that theta upon sine theta is greater than 1, then 2k square will be greater than 1, k square will be greater than 1 by 2. So if k square is greater than 1 by 2, then value of k will be between c. So this gives us k square minus 1 by 2 is greater than 0, which I can write k minus a using a square minus b square, k minus 1 upon root 2 and k plus 1 upon root 2 is greater than 0. So I can represent this on line minus 1 upon root 2 and 1 upon root 2. Inequality is greater than, so I will choose outer region. So I have, see, this is the, here we have the twist. Now from this equation we have k is less than minus 1 by root 2 or k is greater than 1 by root 2. But this is not possible. This is not valid solution. Why? Because Ka represents length. This represents length. Hence, K and A both must be positive. So K must be positive. Second, K is greater than 1 by root 2. Okay, this is fine. But in the first part, we are given that K is less than 1. So this is given K is less than 1. So the right answer will be K less than 1 and greater than 1 by root 2. This is our final answer. 1 by root 2 to 1. We should also consider this given condition where it is already given in the first part that k is less than 1. So let's move to the next question. Read question number 4. This question is interesting. In this diagram, a symmetrical metal plate has been drawn. The plate is made by removing two identical pieces from a circular disc with center C. The boundary of the plate consists of two arcs PS and QR of the original circle and two semicircles with PQ and RS as diameters. So the radius of the circle with center C is 4 and PQ and RS are 4 centimeter also. Show that angle PCS is 2 pi by 3. So first of all, let me write the dimensions PC and CS. Okay, this is CS. Fine. Now I have PQ and SR. So PQ equals to RS equals to 4 centimeter. So this is given 4 centimeter. And this is also 4 centimeter. The length of the bigger circle is given to be, the radius of the circle with center C is 4 centimeter. So this is also 4 centimeter. Now, if I draw a line perpendicular to PQ, if I draw a line perpendicular to PQ and RS, So let's say this is midpoint of PQ and SR respectively. So let's say this is M, midpoint of PQ is M, and the midpoint of SR is N. So using triangle PCM, sine of P will be not sine of P, it will be cos of P. Cos P will be 2 divided by, okay, let me write it in detail. PM divided by PC, which is PM is half of PQ, so this is 2 centimeters, and PC is given to be 4 centimeters. So cos P is 1 by 2. Therefore, P is cos inverse 1 by 2. So cos inverse 1 by 2, it means 60 degree, which is pi by 3. 60 degree. So if this is 60 degree, then this angle, this must be 30 degree, angle PCQ. And also similarly, this angle SCN must be 30 degree, because both the triangles are similar. Now we know that angle PCS plus angle PCM plus angle SCN equals to 180 degree. This means angle PCS equals to 180 degree minus 60 minus 60, not 60, 30. So minus 30 minus 30, because angle PCM equals to angle SCN equals to 30 degree. This means angle PCS equals to 120 degree, which is 2 pi by 3 in radians. That is our final answer. Let's move to the next question. This is B part. We have to find the perimeter, exact perimeter of the plates. So let us move to the previous question, and I will not be solving this, but we will see the concept behind this question. So here we have to find the total perimeter of the metal plate, which is equal to sum of the arc length of PS and QR. See, PS plus QR plus the semicircle plus the length of these two semicircles. Length of these two semicircles. This is our total perimeter of the plate. So arc length of PS and QR can be calculated using R theta. R is 4 centimeter, and theta we have just calculated 2 pi by 3. So it will become 4 into 2 pi by 3. And for semi circle or perimeter of the semicircle, we will do pi into radius of the semicircle. So which is 2 centimeters. So by adding all these, we will be able to find the total perimeter, which is I think easy to calculate. So we will be skipping this question. We will move to the next question. Part C of the same question, show that area of the plate is 20 pi by 3 plus 8 root 3. So now let's move to the same question again. So this is our question. Let me erase this so that you understand better. So now we have to find area of this metal plate. So how we can find the area of the metal plate? So this is important to understand. If I complete the larger circle, if I complete the larger circle, so I have a circle like this. Fine. And now if I connect PQ and RS, PQ and RS. So now I have two segments, this segment and this segment. So let's say area of the larger circle, if somehow I can find area of the larger circle, area of this semicircle, area of this smaller semicircle, and area of these segments. For example, this is 3 and this is 4. So if I subtract 1, 2, 3 and 4 from area of the circle, if I subtract region 1, region 2, region 3, region 4 from area of the larger circle, I get area of the metal plate. Is this clear? If I subtract, 1 is area of semicircle, 2 is again area of semicircle, 3 is area of the shaded region, 4 is area of the shaded region, and we know that area of 1 and 2 region are same and area of region 3 and region 4 are equal. So if I subtract 1, 2 and 3, 4 from area of the larger circle, we get area of the metal plate. So now our objective is to find area of region 1, 2, 3, 4 and larger circle. So let me draw the diagram here once again. This is the circle, and here I have this is PQ, this is segment, this was region 3, this was 1, and here I had 2 and this was 4. I know this is center C. The radius of larger circle is 4. Area of plate. So area of plate is this region shaded by red pen. So area of plate is area of larger circle minus area of region 1, 2, 3, 4. Area of larger circle is pi r square, which is pi into 4 square minus we know area of region 1 and region 2 are equal, so area 2 into area of region 1 minus 2 into area of region 3, because 3 and 4 are also equal. Now this becomes 16 pi minus 2 into area of region 1 is pi r square by 2. So pi and radius is 2. So pi r square upon 2 minus 2 into area of region 3. So area of region 3 is important, and area of region 3 will be area of sector PCQ minus area of triangle PCQ. So this is important. Finally, I have 16 pi minus 2, 2 cancel out. So I have 4 pi minus 2 of area of sector PCQ. So area of sector PC, half r square theta, half r square, r is 4, and theta. See, theta is angle between PC and PQ. So angle between PC and PQ. So we know that this angle we calculated was pi by 3. So this total angle will be 2 pi by 3 plus pi by 3, which means not pi by 3. This was pi by 6. Wait, this was pi by 6. This angle was pi by 6. So angle PCQ will become 2 pi by 6, which is pi by 3. So half r square pi by 3 minus area of triangle PCQ. So area of triangle will be half AB, which is again 4 square, and sine theta. theta is again the angle between PC and PQ will be pi by 3. 16 pi minus 4 pi is 12 pi minus, this becomes 2 into 2, 4 square is 16, so 16 by 2 is 8, so 8 pi upon 3 minus 4 square 16 upon 2 is 8, sine pi by 3, sine pi by 3 is 60, so sine 60 is root 3 upon 2, which gives us 12 pi minus 16 pi by 3 minus minus plus, so this becomes plus, and 8 to the 16, 16 root 3 by 2 means 8 root 3, which finally gives us 12 3 is a 36, 36 pi minus 16 pi is 20 pi by 3 plus 8 root 3. So this is our final answer. This question was really interesting there, that's why I solved this question. Let's move to the next question. Read question number 5. The diagram shows cross section of 7 cylindrical pipes, each of radius 20 centimeter, held together by a thin rope, which is wrapped around the pipes tightly. The centers of 6 outer pipes are A, B, C, D, E, and F. Points P and Q are situated where the straight sections of the rope meet the pipe with center A. Show that the angle PAQ equals to pi by 3 radians. Angle PAQ. See, this is angle PAQ. This is angle PAQ. Now, if you see that if I make similar sectors for rest of the pipes, you will see there are 1, 2, 3, 4, 5, 6. So you will see there are 6 sectors, and if you combine all these sectors together, they will make a complete angle. All okay. This can also be solved by a different method, like second method. So this is I'll explain to you both the methods, method 1 and method 2. This is method 1. So all the sectors make a complete angle, which is 360 degree if combined together. So let PAQ equals to theta. So sum of all the angles of 6 sectors will be 6 theta, and if combined together they make 360 degree, or you can say 2 pi, which is equivalent to 360 degree in radians. So theta becomes 2 pi by 6, which is pi by 3 radians. This is method 1. Now let's go to method 2. So in method 2, I will make a hexagon. I will just connect all the points A, B, C, D, E, F. So this is a hexagon, and if you find the internal angle of a hexagon, for example this angle, if you find angle A, this is internal angle of a hexagon. See, A, B, C, D, E, F forms a hexagon. So you can clearly observe that this is 90 degree. This will also be 90 degree. So angle PAQ plus 90 degree plus 90 degree plus the internal angle of the regular hexagon, which is internal angle gives us how much? 360 degree. So angle PAQ becomes 360 degree minus 180 minus internal angle 180 degree. This is formula for the internal angle. 180 degree minus external angle, and external angle is always 360 upon number of sides of the polygon. So hexagon has 6 sides, therefore 6. So I have angle PAQ, which is 360 minus 180 degree, and minus 180 minus 360 upon 6. This will give us 60 degree, and 180. This reduces to 180, and 180 minus 60 is 120, which gives us 60 degree. So angle PAQ in radians is pi by 3 radians. You can choose any of the methods. This is method 2. This is method 2, and here we have method 1. This is method 1. Let's move to next part of this question. Find the length of the rope. We have to find the length of the rope. Okay, let's have a look at the diagram. Let me erase this. So if I have to find the length of the rope, I will have to add arc length of the 6 sectors and these. So as we have to find length of the rope, so if you see carefully, this rope has one straight section and one curved section around the pipe. So curved section around the pipe and one straight section. So if you can somehow find length of all the straight sections plus sum of all the curved sections. So first we should calculate number of straight sections and number of curved sections. So PQ is first curved section, and here I have second curved section, third curved section, fourth, fifth, and sixth. So 6 curved section for 6 pipes. Similarly, we will have 6 straight sections of the rope. So I will write length of the rope as 6 into length of one straight section of the pipe plus 6 into one curved section of the rope. Curved section of the rope and one straight section of the rope. So which is 6 into length of straight section. So if you see, if we have to find the length of the straight section, this is nothing but r plus radius of 2 pipes, sum of radius of 2 pipes, which is nothing but 2r. And if you have to find length of the curved section, which is nothing but arc length, which is r into theta, and theta we have just calculated, and this value of theta is pi by 3. So now I can write 6 into 2 into r to be 20, and this is given in centimeters, so I will write centimeter, plus 6 into 20 into pi by 3 centimeter. So as final answer, 6 into 12 to the 24, 240, plus 3 to the 6, 40 pi centimeter. This is our final answer. Let's move to the next part of this. So read part C. Find the area of the hexagon A, B, C, D, E, F, giving your answer in terms of root 3. Now you have to find area of the hexagon. So have a look at this diagram. You have to find area of hexagon. So let me draw the hexagon first. So A, B, C, D, E, F, and again A. So this is hexagon. I have to find area of this hexagon. See, this hexagon is a combination of 6 similar triangles: 1, 2, 3, 4, 5, and 6. If somehow we can find area of this one of the triangle, then we can multiply it by 6, and then we can find area of the hexagon. We also know that the side of any of the triangle is 2 into radius, 2 into radius, because it is combining center of the inner cylinder to the center of the outer cylinder. So the length becomes length of the side of any of the triangle becomes 2r, which is 2 into 20. And if you have to find this angle subtended by the triangle at the center, this is 2 pi divided by 6. One complete angle. See these 6 triangles make form. Let me 6 triangles form 360-degree, or you can say 2 pi radians at the center. So for one triangle, angle is for one triangle forms 2 pi divided by 6, which is pi by 3 at the center. Length of triangle adjacent to this angle, length of the side of the triangle adjacent to this angle is side equals to 2r, which is 2 into 20, 40 centimeter. Now area of triangle, area of one triangle will be half. Using half xy sine theta, we can write half into 40 into 40 into sine theta. Theta is pi by 3. Sine 60 is root 3 by 2. So I can like 4 4 is 16, 16 by 2 8. So basically this is 800, and sine 60 is root 3 by 2. So basically this becomes 400 root 3. 400 root 3 centimeter square. So this is area of one triangle. For 6 triangles forming regular hexagon, forming hexagon will be 6 into 400 root 3 centimeter square, which is 2400 root 3 centimeter square, which is our answer. Let's move to the next part. Find the area of the complete region enclosed by the rope. Now you have to find the complete area of the complete region. Let's move to the diagram again. So let me erase this. Now we have to find area of the complete section. We have already calculated area of hexagon. We have already calculated area of this hexagon. Now our objective is to find the outer area. See, the rope consists of one straight section and one curved section around the pipe. So if the straight section forms a rectangle, let me draw this. The straight section forms a rectangle. I will shade this with red color. So this forms the straight section of the rope forms a rectangle, and the curved section of the rope forms a sector. So in total there are 6 rectangles, and in total there are 6 sectors. So if we combine area of 6 sectors plus area of 6 rectangles plus area of the hexagon, we will have total area of the cross section. Again, if we combine area of 6 sectors plus area of 6 rectangles plus area of the hexagon, then we will have area of the complete section. Now for rectangle, length is again 2r, and breadth is radius. For sector, we have radius again r, which is 20, and angle we have already calculated pi by 3. So let us find the area of the cross section. Let's move to the question. So area of the complete section will be sum of area of 6 sectors plus area of 6 rectangles plus area of hexagon. Area of 6 sectors will be 6 into area of one sector, which is half r square theta, using half r square theta, r is 20, square theta, theta is pi by, we have already calculated theta to be pi by 3. So plus half r square theta. Area of 6 rectangles means 6 into length into breadth. Length was 2r, and into breadth, this is length, and into breadth, which is radius only, so 20. This is area 6 into area of the rectangle, plus area of hexagon we have already calculated, which is 2400 root 3 centimeter square. So on calculation, this gives us 3, 400, 1200, 3, 6, 6, 400 pi plus, and here we have 4800 plus 2400 root 3 centimeter square. So this is our final answer. Students, read question number 6. The diagram shows triangle ABC, in which ABC equals to 90 degree, AB equals to 4. ABD is part of a circle with center A. Area of sector is 10 centimeter square. So area of this sector is 10 centimeter square. This sector. So area of the sector is area of sector is half r square theta. Now we have to find angle BAD. Let angle BAD be theta. Let angle BAD equals to theta. So now we have to find theta. This area of the sector is already given to be 10 centimeter square, and radius is also given to be 4. So the value of theta becomes therefore theta becomes 1.25 radians. This is our final answer. Let's move to the next part. Find the perimeter of the shaded region. Let's have a look at the diagram. See, we have angle ABC as 90 degree. This is 90 degree. We have angle A as well in radians, which is 1.25 radians. We have to find perimeter of the shaded region. So we have to find length of BC, length of CD, and length of this arc BD. We know that in triangle ABC, tan of theta, theta is angle BAD. So tan theta will be how much? BC upon AB. So using the value of theta as 1.25 and value of AB, this is 4 centimeters. This is 4 centimeters, and this is given to be 1.25 in radians. So always change your calci to from degree to radians. You can calculate length of BC, and which is 410 1.25 radians. And similarly, you can also find length of AC as cos of theta is base upon hypotenuse. So base is AB and hypotenuse is AC. So you can find length of AC as 4 upon cos of 1.25. So from this you have BC and AC, but you need to have length of DC only, this CD. For shaded perimeter of shaded region, you have to find length of CD only. So you will subtract length of AD from AC. For CD length, we have AC minus AD, which is 4 upon cos 1.25 minus 4. So let's move to the next slide. Perimeter of the shaded region equals to length of BC plus length of DC plus arc length BD. Length BC we have already calculated, 410 1.25 radians, plus DC also we have already calculated, AC minus AD. AC is 4 upon cos 1.25, 4 upon cos 1.25 minus AD. So AD is 4 centimeter equal to radius, plus arc length. Arc length is R into theta. So R is 4 and theta is 1.25 centimeters, which will give us total perimeter equal to 25.7 centimeter. This is our final answer, and this is end of part 1 video of circular measure. We will be continuing solving questions on circular measure in the upcoming videos as well. So see you in the next video. Take care. Thank you so much.